In the previous video, entering and solving equations in EES, we showed how to enter some simple equations in EES and obtain a solution. This video introduces a unique feature of EES, which is units. Variables in engineering problems typically represent physical quantities, and therefore they will have units. Unit errors are very common when solving these types of problems. EES allows you to not only assign a value to each variable, but to also assign a unit to each variable. This is an incredibly useful feature of EES because the unit consistency of the equations are then examined by EES, and any unit conversion errors are flagged. Further, EES facilitates the process of converting between units by including a large number of built-in unit conversion factors. EES can also display output variables in dual units. These features will be discussed more completely in this video. So let's calculate the area of this rectangle, that is W equals 12 inches high by H equals 2 feet long. And I'd like the answer in centimeters squared. Enter the width and the height into EES. Note that the variables W and H both have been assigned a value. It is also possible to assign units to these variables, and the easiest way to do this is by right-clicking on the variables in the solutions window and then entering the units. Let's convert W and H both to centimeters. The easiest way to do this is to use the convert function in EES. The convert function requires two arguments. The first argument is the unit to convert from, and the second is the unit to convert to. The function itself simply returns the relevant conversion factor. So, for example, convert meters comma centimeters would return 100 centimeters per meter. So the inputs W and H are converted to centimeters, as shown here, and you can see that the units of these variables are adjusted in the solutions window. We can next compute the area. Notice that the area A has no units assigned to it, and EES has automatically checked the units of the equations and identified that there must be a unit error. Select the Check Units button in order to see the specific equation that has the unit problem. Entering the appropriate units for A will remove this unit warning. It is possible to see the units that EES has pre-programmed in it by selecting Unit Conversion Information from the Options menu. Navigate to the dimension of interest, in this case energy, and select any two defined units in order to see the unit conversion factor between them. For example, here between gigajoules and therms. So let's do one more problem. Let's compute the weight of a 175-pound man on the moon, where gravity is only 5.3 feet per second squared. We're going to take the approach that is outlined here for dealing with units. First, convert all of the input quantities to base SI units, i.e. newtons, meters, seconds, etc. These are completely self-consistent, and therefore no unit conversion should be required while actually doing the problem. Once the problem is completed, any outputs can be converted to the units that are most appropriate, or alternatively we can use the dual unit output feature in EES. Mass and gravity are entered and converted to base SI units. Note that the units of the constants, for example the number 175, can be entered directly in square brackets in the equations window. The convert function is used to convert from pound mass to kilograms and from feet per second squared to meters per second squared. The weight is simply mass times gravity. Because we are doing this problem in base SI units, the value of the weight that we calculated, which is a force, must be in units of newtons. To see weight in a different unit, for example in pounds force, either define a new variable and convert W to pounds force, or, more conveniently, just use the dual unit feature in EES as shown here.